So we have done with this particular exercise about how you can assert set equality for the return value in the previous lecture part. So let's now continue with about the basics of discrete math, and then I'll do a little bit of examples with you about how to do relational operations. But let me just go over the slides and then tell you what you should really study on your own, because that has been already covered in the prerequisite course 1090. It's a math review just about the basic definition about set membership, and etc. So you can go over them. Okay, just make sure you're comfortable with set comprehension versus set enumeration. And then also we got set relations over here about subset versus proper subset versus equality, right? We also touched upon the set equality in the exercise previously. And also about set operations, you can do union, you can do intersection, you can do difference. Just make sure you understand the definitions over there. And then also for power sets will be quite important here to actually understand how we can create relations out of two sets. So you may want to review this one as well, power set. And the size of the power set will be exponential on its operand set. Okay, and also tuples, we also support tuples type in IFO. So understanding about tuples also will be beneficial. And later on, you're going to see that whenever you're working with, let's say, relation set will also function in math models. Either you have to work with pairs, which is very similar to a tuple, or you have to work with tuple, either way. Okay, so that's about cross products and how you can define relation, etc. Cross products, and we'll get to relation definition in the next slides. And also about relations here. So a relation, so here's one example, and also you got empty relation. That's always the base case for any collection. And then you can see the example here is about cross products and take the power set. Okay, and we talk about domain. We talk about also range for a particular relation. That's I will give you some example about how you can run the math models commands or queries in a moment. Okay, to see the correspondence. But mathematically, you should understand how the basic concepts still should be understood. And for relations, we also, there's a power set of the cross product. So this expression here is very important. So you may have memorized this from the previous course. I hope you did not. But if you did, please make sure this is the time to really get it through. So it's a very important mathematical concept in order for you to understand how to write proper contracts. Okay, we'll talk about relation definition here, and that's the notation for relation. You learn about it in 1090. Okay, so let's say we got some relation, we got domain, we got range, and also we got inverse. So I will give you some example about domain and range in just a moment. Okay, but of course you got to review the basic definition. And also we got domain restricted and also domain subtracted. So whenever you see this, also range restricted and also range subtracted. So these are all queries, which means given if you say relation dot domain restricted some set. Right? So let's say for this example here, you can see this particular query over here does not modify the context object R. It does not. What it does is it's going to return just another relation, brand new relation objects, which will correspond to when you do domain restriction on R. And as for domain restriction, domain subtraction, range restriction, and range subtraction, that's also something you learned before. So to really review, you can actually look at this particular slide to see both the definitions and also examples. You're expected to do that. Okay, but I will do just one of them as an example with you in just a moment. Okay, and we'll talk about also overridden. I also do some example with you. That's also very important. And also, okay, that's just like an anatomy of how you can do overriding. I'll show you that. Okay, and then we talk about functions. Function is like a specialized form of relation. Okay, so you can see exactly what I meant by specialized form. That's also something you should have known already. Okay, so I'll let you read the example here. So there's some little quizzes over here to help you. Okay, so I will assume that you're gonna read it. Okay, just make sure. Of course, if you're completely comfortable with the basics about discrete math, you can definitely skip the slides. But we'll test that, in the quizzes. Okay, and then we talk about set comprehension for some set functional property. Okay, you can also review it. Okay. And also and by the way, we also talk about what it means for vertical bar and what it means for bullets point in this particular course context. We addressed them a few times already in the Q&A session. If you still got doubts, you should really check back in the Q&A session to see what these notation really mean. Okay, so we got function. Function might be injective. Okay, you should really review what injective function really means, and also surjective, and also bijective, right? So depending on what application we're talking about, maybe its mathematical model should really correspond to either an injective function, a surjective function, or a bijective function. That's something you also want to review. Okay. Okay, and then we got some visual illustration over here. Okay, you can see that. Okay, and then this is just a summary of what you can use from the relation class from the math models. Okay, let me just give you one example. So the command would be, for example, if you say domain restrict, if you say R, which is a relation, if you say R.domain restrict, that one is a command call that should stand alone by itself. You should not assign this call to another variable. That wouldn't compile. On the other hand, if you say domain restricted, you can see that in the past tense over here. So if you say domain restricted, so that means when you say R.domain restricted, you're going to return just another new relation. And that relation is brand new, independent from the context objects. So notice the difference between these two. So this, the command version in this column over here, so these might be the commands you want to use in the implementation of your abstraction function, like a model query. On the other hand, for the query over here, so these are the query that can be used to build more complicated expression over there to create a Boolean expression, in which case you can use them in the contracts, right? So notice the difference. We also explained that also when we talk about abstraction function in the previous week. Okay, so this table here just for your reference. Do you need to memorize these names? No, you don't have to. You just have to know the difference between commands and also queries. We'll do some example in just a moment. Okay, so now we got commands, we got queries, exactly what I said. Okay, you can just review these points over here. Okay, so what I will do is I want to do a few examples together with you, and this is just one of them. I'm going to show you on my iPad, and then hopefully those will also get you started with the relation operation. Of course, you shouldn't just rely only on the examples I showed you. It's only mainly as a starting point. You should really explore the relation class further when you actually do your lab number 2. So let me now switch to my iPad, and let's say let's start with the basics. Okay, let's say we have a relation over here, and you can think about each relation is like a set of pairs or a set of tuples. So here, let's say we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. We have a relation with 9 pairs. So if you simply say r.count, it's just going to give you 9. Okay, that was a very easy one to understand. Okay, just about how many pairs you actually got in that particular relation. And now the very basic question we can ask as queries would be, what about R the domain? You can think about domain would be just a collection, the set of first values in the pairs. So in this case, the domain over here would be by selecting A, B, C, A, B, C, D, E, and F as a set, right? So what you will get is it's going to return a set if you see the return type of domain in the relation class. So it's simply going to return a set. It's going to be without any duplicates. So it will be A, B, C, D, E, and F. Okay, so that's the domain. What about the range? Range will be the other elements in the pair. So range will be, let me use maybe blue here. So the range will be basically the second element. So it'll be 1, 2, 3, 4, 5, 6, 1, 2, and 3. Collect all of them as a set. So what you will get is it's going to be 1, 2, 3, 4, 5, and 6. Of course, without any duplicate. So you don't have to repeat 1 twice, for example. So now about the image. So this is something interesting over here, right? About the image. So this will also highlight a fundamental difference between relation and the function. Let me talk about relation case first, and then I will just highlight briefly about what a function case would be. When you do image over here, either you can simply say r.image, and then you can simply pass either a single element or a set of elements. You can check the corresponding queries in the relation class. I'll leave you to that. But I'm just calling the version where just a single element over here. And then you can also try to get the image, for example, using the square brackets notation. So this square brackets notation is a little bit like a function application notation, but you can use either one. Either this or this. Either one is fine. depending on which one you feel more comfortable. Okay, so let's talk about image over here. Basically, image, you have to pass a single domain value over here. And the value you pass either is a valid domain value, which means it might be a value that's in this particular set, or maybe outside this particular set. It depends, right? Let's consider case number 1. So when you pass A over here, you can say A is definitely a member of the domain as we calculated before. So what it will do is, it's going to collect basically all the values that are mapped by this particular domain or key value. Okay, so now you can see what do we get. Let me just highlight it quickly. You can see we'll talk about A here. So which pairs are associated with the search key or domain value A? This is 1, we got A1. This is 1, we got A4. And okay, we only got A1 and A4. Yep, so that's multiple. That's good. So now, so that means in the relation case, a single key or domain value might map to multiple range or range values. Okay, multiple is possible, but in the case of function, it's not possible. Okay, so that's a quick highlights. So now how do we, what will be the result value over here? So now it would be, for example, A1 and also A4. So that will be 1 and 4. So this is the result for the relational image. So remember we said function is simply a specialized form of relation. For function, okay, so now let's say for function. For function, so basically each domain value will map to at most one value that's in the range. So I'm pretty sure you learned about this definition here. So at most is really the key over here. Okay, so now let's say for some reason, let's say your model happens to be is actually of type relation. Let's say your model, okay, is a relation. However, effectively is also at the same time a function. So what does that mean? That means even though the type of the object is actually relation, but its property makes it that it is actually a function. In that case, whenever you say R the image A over here, you may have to do something like, you want to say maybe R the image, whatever value you pass over here, you want to say number 1, the size over here could be the count, that is a set, is exactly equal to 1. So that's making sure is mapped to at most one element there. Okay, not for this particular A, because A does map to multiple value. I'm just saying that in case if you're trying to say I do have some R of type relation, however R is at the same time also a function. In that case, let's say we don't want to change the declaration to be of type function. Let's say we still want to keep the type as relation. In that case, every time you say R the image over here, whatever value you pass over here, if you believe the value you pass over here is a valid domain value for the underlying function, in that case you had to say the return image set is actually of size 1. So that's something very important for you to note. Okay. And what about another one here? What about when we say R the relational image of G for R over here? So now you can see G over here is outside the domain of R. So that means it's simply just going to return an empty set. Okay, it's still a set, but just empty with no elements. Okay. All right. And of course, whenever you say R the image dot count is equal to 1, in that case, you're saying there's a singleton set, right? Hopefully you learned about that term as well. Singleton set. Singleton set is simply a set with exactly one member. Okay, no more and no less, just exactly one. Okay, so these are the basics about domain, range, and image. So let me talk about something slightly more advanced. It's something called overridden. Okay, overridden over here can be decoupled into 2 steps when you calculate it. Okay, whenever you do overridden, you can actually pass a set of items over here, a set of pairs basically, and or you can see other options there in the relational class. You can also pass a single elements. You can look it up yourself. But let me just talk about mathematically. You can definitely pass a set of pairs. So now the way to do it is you can think about we are undergoing 2 steps over here. We're saying that number 1, you should really find out all the pairs. First of all, you want to find out here. Let's say this input over here is simply just T. Okay, first find out T the domain. In this case, the domain will be A and C. Okay, so the domain will just be A and C. Let me make it a little bit larger for you. You can see the domain is A and C over here, right? So what you want to do is you want to say from the input relation here, right? When you say R dot overridden, want to say A3 and C4. You can, first of all, delete all the pairs that's associated with A and C, the domain. So that's effectively doing domain subtraction. Okay, that's why you see domain subtracted over here, right? I'm just using the query version so we can still get a relation. But for convenience of illustration, let me just operate directly on this particular relation just to show you. First of all, we want to do domain restriction. So get rid of all the pairs whose first elements are either A or C. So this one should go away. A, C, A, C. Okay, so these are the 1, 2, 3, 4. These 4 are gone. So that's why here you can see the intermediate result we have over here is simply what we saw, what we see here: B2, B5, D1, E2, and F3. Right. So these are what's left over here. That's a step number 1. Step number 1, you want to get a domain subtraction on the domain of the set over here, basically. Okay. And then the second one over here, what we want to do is we want to do a union, because we know that eventually we want to make sure A3 and C4 are the only mappings we want to have related to A and C. So what we want to do is we just want to do union over here. So we want to union A3 and C4 to whatever that's there. So now you can think about what we're going to do is we're going to extend this particular relation here by the input A3 and C4. So A3 and also C4, the orange part. So eventually, so 2 steps again: domain subtraction, and then do the union. So these are the 2 steps. Okay. So eventually, the answer after the overriding will be we got relation B2, B5, D1, E2, and F3. So these were not affected by the first step of the domain restriction. And step number 2, you want to make sure A3 and C4 as specified the input are also included. So that's a relational overriding. Okay, it's a very practical and also very useful operation for you to know. And also we also got something called function overriding. But for function overriding, it's also very similar. It's just that in the first step, when you actually try to get rid of the pairs over here, it's guaranteed for each domain value it maps to at most 1 value over there, rather than, for example, you can see over here in the case of relation you have to get rid of A1 and also A4. But in the case where it's a function, A is guaranteed to be mapped to at most 1 element there, right? So just another example to show you. Okay, but so relational overriding and also functional overriding are very similar operation, but relational overriding is definitely just more general. Okay, let's just do one more example over here. So this part here is exactly what's on the slides about the various definitions of the operations. I'm gonna leave you to study them. Okay, that's already covered in the previous course. So let me just give you one example about domain subtraction, which we already talked about briefly when we talk about overriding. But let's just do one example here. Let's say we know, so far we talk about conceptually this is the relation that we are working with over here. But how do we create that at runtime using the math models class? Okay, let me show you here. So there are different ways you can do it. One way to say is you can say, let's say we got R is of type relation. Let me just make it a little bit bigger for you. Okay, let's say R is of type relation here. And then we are saying that we say create R that make from tuple array. So this is one constructor you can call. And then we'll simply say array over here. That's an array. And then each element there will just be a tuple. The way you create a tuple is by using square brackets. And then you list the elements over here, right? You're going to say A1, B2, C3, and etc. That's how you create a new relation from the array of tuples. If you know beforehand what the elements should be, or you can simply run a loop to actually create one by one. Okay, so then, and then what I want to do is I want to do a domain subtracted, right? Domain subtracted, in this case, for this particular query, is going to take a set, ds. So that's why I say ds that make from array. You can see ds is simply just a set, right? And then when I simply say create from array, similar, you can see this is the array, and then I'm simply just have one element in the array, just A. Okay, so you can think about the ds over here. We are really just doing over here, just A over here. So when you say domain subtracted, So subtracted over here is a past tense, is a query, which means it's not going to modify the context object relation over here. It's not going to. It's going to instead return a new relation that's going to correspond to with the domain value A deleted. That's what's going to happen here. Okay, so you can think about conceptually over here, it's just going to return. So the green one, right? So let's say this return value will be the green one. It's just going to create another relation over here. So with all the A deleted. So we still got B2, and also we got C3, and also A4 is not there anymore. So also we got B5, and also we got C6, and also we got D1, and also we got E2, and also we got F3. You can think about this is the relation that will be returned from this particular query over here, right? That's exactly what's going to be returned. Okay, so hopefully so far it makes sense. And then this is just some Boolean test to actually make sure we do have that particular operation successfully applied. Okay, so we want to make sure now the return relation, which is T, is a brand new relation. You can think about this as T. Okay, so this guy over here is R. So we are not modifying that relation, just a brand new object for relation. And then for T, that should not be equal to R. So now tilde is actually going to call the is equal query in the relation class, which has been properly redefined already. So you don't have to worry about that part. You can just use it. And then for T, because we have T represent the domain restricted version of R. So now T should not contain the domain value A, whereas R should still contain A as a domain value, right? That makes sense. Finally, I want to show you sometimes you might you can think about calling domain subtracted could be useful when you're writing contracts, because it does return something for you to maybe further manipulate it, so you can still create Boolean expression from there. On the other hand, let's say when you're trying to let me use a different color here. When you're trying to, let's say, trying to implement the model abstraction function, in that case, you may actually want to call the command version. In that case, let's say r dot domain subtract. When you're calling this, what you're doing is you're really modifying the context object relation over here with, let's say, the same ds. Remember, ds is simply just A over here, right? So now for the pink operation over here, we are really going to modify the target relation. So now, which I'm just going to modify this directly, right? Remember, this is R, right? Remember that. So I'm going to delete is a domain subtraction. So every pair whose domain value is A is going to be eliminated. So now A1 will go away, and also A4 will go away, pretty much like what we did before for the overriding. So now after this, you can see so now we are really comparing the R after the domain subtract after this. So R and also T, now they should be equivalent relation. So you can see T equivalent to R should be true, and also for T, it does not have the domain value A as before. And also now, since R has also been changed, so R, the domain value, does not have A. Okay, so it's a very small test, but hopefully that really give you the idea about the distinction between using command versus query for the relation operation. You have to judge. Okay, let me just write down the principle for you. So for command, that's also summarized in the slides. So for command, you should really use them in the implementation of model, the abstraction function. On the other hand, when you talk about the query, which can be a returning value for you to further manipulate, so those will be for contracts. Okay, so what you want to distinguish between these two. Alright, so that's about the examples I would like to give to you. And then the next step will be we want to apply these ideas into abstracting the birthday book application.